Hey everybody, today we are going to talk about linear programming. Okay, what is linear programming? There's a common mathematical problem that's a process called optimization. This is a process where you're trying to find the minimum or the maximum value of some quantity. Okay, one way you can do this is called linear programming. So, linear programming model consists of a system of linear inequalities called constraints. It also has something called an objective quantity that can be minimized or maximized. So, in order to find the minimum or maximum value of an objective quantity, you first find all the vertices of the graph of the constraints. So, you graph the constraints first, you find the vertices. Then you evaluate the quantity at each vertex. The smallest of these is called the minimum, and the biggest of these is called the maximum. Okay? So let's look at a couple of these. Okay, find the minimum maximum values of c equals 4x plus 5y. Now I've got three constraints. X is greater than or equal to 0, y is greater than or equal to 0, and x plus y is less than or equal to 6. So let's graph these first. X greater than 0 is going to be anything on this side. Okay, y greater than 0 is going to be anything above this line right here. Okay, so that's why I have this quadrant here. Now, x plus y is less than or equal to 6. If I want to put this in slope-intercept form, that's going to be this. Okay, so my y-intercept is going to be 6, and my slope is going to be -1, so this is going to go down to here like this. Okay, and it's going to be less than or equal to that, so it's going to be inside here. So basically, this is all the points that will satisfy all three of those constraints. Now, I am not interested in all the points in here. I am only interested in the vertices. Okay, so there is a theorem that says the vertices are the only places where the minimums and maximums occur. Okay, so I've got one here at 0, 0. I've got one here at 6, 0. And I've got one here at 0, 6. Okay, so I'm going to take those three corners. I'm going to plug them in here. So 0, 6 is going to be, C is going to be 4 times 0 plus 5 times 6, which is going to be 30. Okay. And then 6, 0 is going to be C equals 4 times 6 plus 5 times 0, which is going to be 24. And then 0, 0, probably do this one in your head. C is going to be 4 times 0 plus 5 times 0, which is just going to be 0. So here is my max. Here is my minimum. Okay, any other point that I would choose that would satisfy these three constraints, so I could pick this point right here, or any point inside here, is going to be somewhere between 0 and 30. Okay? So this would be my maximum. If I was going to want to like maximize my profit, this is where I would want to operate, would be at 0, 6. Okay, so here's what I'm going to let you do. I'm going to let you pause this and do this one real quick, and then jump back on and see how you did. Okay, x greater than or equal to 2 is going to be anything to the left or the right of that. X less than or equal to 5. It's going to be right here. That's going to be anything to the left of this. So I'm going to be between those two things. Y is greater than or equal to 1. So I'm going to be above that, and y is less than or equal to 6. So I'm going to be in here. So I'm going to be in this rectangle right here. This is my solution set. Okay, and my vertices are going to be at 2, 1, at 2, 6, at 5, 6, and at 5, 1. Those are the only points I'm concerned with. Okay, so now I'm going to go ahead and I'm going to get my objective quantity, and I'm going to take the point 2, 1, and I'm going to plug that in. So C C will equal 3 times 2 plus 4 times 1. That's going to be 6 plus 4 is going to be 10. Okay, and then 5, 1. C is going to equal 3 times 5 plus 4 times 1, which is going to be 15 plus 4 would be 19. So I know this one's not my maximum at this point. Okay, we'll go to 2, 6. C is going to equal 3 times 2 plus 4 times 6. That's going to be 24 plus 6 will be 30. So this is also not my maximum, and this one is definitely not my minimum either. Okay, and then 5, 6. C is going to equal 3 times 5 plus 4 times 6. So it's going to be 24 plus 15 would be 39. So here's my max. Here's my min. Okay, so hopefully that's what you got. Here's another one I'd like you to try before you watch me do this. So go ahead and pause the video and give this one a try. Okay, so x is greater than 0. That gives me this. I'm going to be to the right here. Y greater than 0. It's going to be above this. And you'll find a lot of times that you're operating in the first quadrant. You don't always have to, but a lot of times other answers don't make any sense. Okay, 4x plus 3y is greater than or equal to 24. So I could make a table with that. And if I plug in my zeros, 0 for 4 means that y is 8. And 0 for y means that x is 6. Okay, so 6, 0 is going to be right here. And 0, 8 is going to be right here. So I'm going to get this line right there. And I'm going to be greater than or equal to this. So I'm going to be above this. Okay, so this is going to be out here. Okay, and now I've got this last table here. So let's see, we'll make this slope-intercept form. So 3y is greater than or equal to negative x plus 15. And then y is greater than or equal to negative 1/3 x plus 5. Okay, so my y-intercept is 5. My slope is down 1 to the right 3. Okay, so my line's going to look like this. And I'm going to be above that. Okay, so my shaded region, this is going to meet out here at 15. So my shaded region is going to be this region up here. Okay, so I need to find where does this thing intersect over here, and that's going to be at 15, 0. Okay, so I've got a vertex here at 0, 8. I've got another one right here at 3, 4. So let's test those. Okay, so 0, 8 C is going to equal 6 times 0 plus 7 times 8, which is 56. Okay, then 3, 4, C is going to equal 6 times 3 plus 7 times 4. Okay, that's 28 plus 18, 38, 46. Okay, then we're going to try 15, 0. Okay, so C is going to equal 6 times 0. Whoops, 6 times 15, sorry. Plus 7 times 0. So 6 times 15, that's 3 times, so it's 90. Okay, now here's the thing. This is going to be your minimum. Okay? But you should be able to look at this equation and realize that I can pick a point way up here. Okay, and it's going to be bigger than 90 if I plug that in there. So let's say I picked the point 100, 100. Well, that would be 600 plus 700 would be 1300. This thing is not going to have a maximum. This is just because I can keep going up there and get bigger and bigger numbers. So this is one that has no maximum. Okay. So there you go. Okay. Finding the maximum profit. So you own a factory that makes metal patio sets using 2 processes. I thought I had 3 of these here. I guess we did 3. Okay. You own a factory that makes metal patio sets using 2 processes. The hours of unskilled labor, machine time, and skilled labor per patio set are given in the table. Okay, so the first process, now you can use up to 4,000 hours of unskilled labor, up to 1,500 hours of machine time, and up to 2,300 hours of skilled labor. Those are my constraints. So I only have so many unskilled workers, and they can only work so much. That's why I can only use up to 4,000 hours. Okay, the machine, if the machine's going all the time, it's going to be up to 1,500 hours. And my skilled labor can be up to 2,300 hours. Now, process A earns a profit of $80 per set, and process B earns a profit of $40 per set. How many patio sets should you make to by each process to maximize profits? Okay, so the first thing I need to do is I need to find my objective quantity. Okay, my objective quantity, the thing I want to maximize or minimize, is going to be the profit. So my profit is going to be 80 times process A plus 40 times process B. Okay, so I've got that down. Now I need to get my constraints. Okay, so my constraints okay, so in process A, I have let's see, I need to have my process A is going to be 10 hours of unskilled labor, plus I can have 1 hour by process B, and that has to be less than or equal to 4,000. Okay, that's my unskilled labor. So I can have 10 hours of this by this process or 1 hour of that. Okay, next I've got 1 hour of A. I don't need this one here, so I'll get rid of Okay, plus 3 hours of B, that's my machine time, has to be less than or equal to 1,500 hours. And then the skilled labor is going to be 5A plus 2B, and that has to be less than or equal to 2,300 hours. Okay, so the next thing, now I've got my objective quantity, I've got my constraints, I need to graph this thing. So here's my graph. Okay, here's 10A plus B is 4,000. Here's the 5A plus 2B is 2,300. Here's the A plus 3B is 1,500. Okay, so where are my corners here? Well, I've got one corner is going to be here at 400, 0. I've got one here at 0, 0. Now here's the thing. If I don't make anything, I can't make any money. Okay, this is going to be 0, 500. This is the point 300, 400. And this is the point 380, 200. Okay, so those are the points that I need to check in my objective quantity. All right, so let's do that. So P is going to equal 80 times, what is that? 0, 500, so 80 times 0 plus 40 times 500. So this is putting all of my effort into just doing process B. Okay, so this is 0, and this is going to come out to be 20,000. Okay, so I make $20,000. Okay. What if I do the opposite? What if I put it, because this has all the profit, this has got lots more profit, right? So 80 times I can make 400 of these this way, plus 40 times 0. Okay, so that's going to be $32,000. So it would be better to operate here than up here. Okay, what about in between? So 300, 400. 80 times 300 plus 40 times 400. Okay, so that's going to be 16,000 plus 24,000. That's going to be 40,000, I believe. Let's just double check it so we don't make a mistake. 300 plus 40 times 400. Yeah, that's 40,000. Okay, so even though I make more profit by using process A, it uses up more materials and hours than process B. So I actually, by making a little bit less, I actually make more money. Okay, now we'll check the last one. 380, 200. So 80 times 380 plus 40 times 200. Okay, so 80 times 380 plus 40 times 200. That's 38,400. I actually have one more point that I could check, and that's the 0, 0. So 80 times 0 plus 40 times 0 means that I make 0. So this is my minimum. This is my max right here. This is where I want to operate. I want to make 300 tables by process A and 400 tables by process B, and I will make the most profit that way. Okay? All right, so I got a little assignment here for you. There's only 6 problems on this thing. You're going to need some graph paper, but have a good time with that. I'll see you guys later.